The next question. For the system SO2 Cl2 gas giving SO2 gas plus Cl2 gas at 648 Kelvin temperature, the equilibrium constant for the system is 3.2 into 10 to the power of minus 3. So we are given equilibrium constant K at 648 Kelvin temperature for the above system as 3.2 into 10 to the power of minus 3. If at a given instant concentration of each of the substances is 0.05 molar, then the system A is at dynamic equilibrium, moves backward direction, moves forward direction, is at static equilibrium. So the system is SO2 Cl2 gas. It's also gaseous equilibrium system to give SO2 gas plus Cl2 gas. It is mentioned that at a given instant, we are not given that it is only at equilibrium at any time from the start of the reaction. At some point of time, that is at T, it's not T equilibrium. The concentration of each of the substances is 0.05 molar. This is also 0.05 molar. This is also 0.05 molar. So if the concentration of each of the substances is known at a point, then the system is at equilibrium or not. How can we find out? For this purpose, when the concentration of all the reactants and products for a given reversible system is given, then we need to find out what is called reaction quotient. So the problem is based on reaction quotient and equilibrium constant. This reaction quotient is represented as Q. If it is in terms of concentration, QC. If it is in terms of partial pressures, QP. And this reaction quotient Q is to be compared with equilibrium constant K. But what is the difference between the two, reaction quotient and equilibrium constant? This reaction quotient Q is nothing but the ratio of product of molar concentration of products to the product of molar concentration of reactants at that instant of time. What is it? The ratio of product of molar concentration of products. What do you mean by that? Products are sulfur dioxide and chlorine. So the concentration of sulfur dioxide is 0.05. That of chlorine is also 0.05. So this product is nothing but the product of concentration of products of the system by product of concentration of the reactants. In this particular case, only one reactant is there, that is nothing but 0.05. Therefore, this get cancelled. It is 0.05, which is nothing but called reaction quotient. Then how is it different from K? That is equilibrium constant K. This equilibrium constant K is molar concentration of the products to the product of molar concentration of the reactants only at equilibrium. Got the difference between reaction quotient and equilibrium constant? Reaction quotient is the ratio of product of molar concentration of the products to product of molar concentration of the reactants, but at any time from the start of the reversible system, not necessarily be at equilibrium. Whereas equilibrium constant is the product of molar concentration of the products to product of molar concentration of the reactants only at equilibrium. So K equilibrium is already given to us as 3.2 into 10 to the power of minus 3. Now we need to compare these two. The system always tries to move to attain the equilibrium. So here K equilibrium is 3.2 into 10 to the power of minus 3 and Q is calculated and is worked out to be 0.05, which can be written as 5 into 10 to the power of minus 2. From these two values, what do we understand? We find Q is greater than K. In other words, reaction quotient is more. That is, the product of molar concentration of the products is more than equilibrium constant. Therefore, the system always, that is when Q is greater than K, moves in the backward direction of the reversible system. That is, if K is greater than Q, forward direction reaction is favored. While Q is greater than K, backward direction reaction is favored. While if Q is equal to K, the system is at dynamic equilibrium. These are the conditions. So now since Q being greater than K, the system moves in the backward direction. Let us see among the options given. This option is there or not. So the system is at dynamic equilibrium. Q and K are not equal, therefore wrong. Moves in backward direction. Since Q is greater than K, the system moves in the backward direction reaction. That is, SO2 reacts with Cl2 to give SO2Cl2. Moves forward direction is wrong. Static equilibrium. The system will not remain both forward direction reaction and backward direction reaction being stopped. Therefore, there is no question of the system being at static equilibrium.